Hi guys, my name is Melissa, and in today's video we're going to be talking about angles and triangles and percentages. So, since we have a lot to cover today, we'll probably only be going over the basic concepts and example questions for each topic. So angles and triangles is going to be one topic and percentages is going to be the other topic. But since we have enough example problems, we won't do practice problems today, but we'll just go over the concepts for, for both topics. And so for angles and triangles, our first concept is that we're going to suppose L is a straight line while L1 and L2 are two other straight lines that meet at point on L. So this is a straight line, and we have L1 and L2 that meet at a point at L. Then L1 forms an angle called A, and L2 also forms an angle called C. And then between L and L2, we have an angle B. And so we know that angle A plus angle B plus angle C is equal to 180 degrees, like this. Then also, our second scenario is that given that L1 and L2 intersect at the point O, we're going to have an angle A and B, and so angle A is going to be equivalent to angle B in this case. And so these two angles are going to be equivalent and they're facing each other. Now, in our next scenario, if a point P on a line L travels one complete rotation around a fixed point O, it has traveled 360 degrees. So point P travels around, and so it has traveled 360 degrees. And so that is by definition, because by definition a circle has 360 degrees, and so P rotated around a circle, and so it went through one complete rotation of 360 degrees. And so our second concept is that given any triangle, the sum of its three interior angles is 180. So for any triangle, we have three angles. And so the three angles are going to add up to 180 for all triangles. And so for example, if we have this triangle, angle A plus angle B plus angle C is going to add up to 180 degrees. And concept 3 is that given a triangle, the exterior angle is the sum of its two opposite interior angles. So this is kind of a tricky concept, but so let's look at this diagram. So we have angle A, B, and C. Now, if we extend this side, then if we extend this side, we have an exterior angle that forms, and that angle is going to be D. So you can see that D is not a part of the triangle, so it's an exterior angle. And so the other two interior angles, angle B and angle C, is going to add up to angle D. And to explain why this happens, since we have a straight line, we know that angle A plus angle D is going to equal to 180 degrees. And that we can confirm in the first topic, where we have a straight line and with angle that forms 180 degrees. And so since we extended the line is a straight line, so these two angles are going to add up to 180 degrees. Now, based on what we just learned above, we learned that the sum of the three interior angles of a triangle is always 180 degrees. So we know that 1, angle A plus angle D is equal to 180. And 2, we know that angle A plus angle B plus angle C equals 180 degrees. Now we know that from the first equation, we know that angle D is equal to 180 degrees minus angle A. And from the second equation, we know that angle B plus angle C is equal to 180 degrees minus angle A. So we know that since both are equal to 180 degrees minus A, we know that angle D must be equal to angle B plus angle C. Now let's take a look at our next concept. So we have given a right-angled triangle with sides A, B, and C, where C is the longest side. We call C the hypotenuse. So it's a right-angled triangle, and so the slanted line is going to be our hypotenuse. And these are going to be our other two sides or other two legs of the triangle. And so we have a Pythagorean theorem. We have something called the Pythagorean theorem. And so it states that C squared equals A squared plus B squared. Right, so the hypotenuse squared must be equal to A squared plus B squared. And and we can use the Pythagorean theorem only when it is a right triangle. Right, so we only use the Pythagorean theorem when the triangle is a right triangle. And also, it's really helpful if you memorize some common Pythagorean triples. And so the Pythagorean triples are combinations of A, B, C that are really common. And so examples are 3, 4, 5, 5, 12, 13, and 6, 8, 10. So the longest one, 5, let's just check if 3, 4, 5 fits the Pythagorean theorem or not. And so it's one of the most common Pythagorean triples. And so since C is 5, 5 squared is equal to 3 squared plus 4 squared. And we can confirm that because 25 is equal to 9 plus 16. And then oftentimes we use the Pythagorean theorem to find one side. So for example, if we know that A equals 3 and we know that B equals 4, then if we know the Pythagorean triple identity or Pythagorean triple, we know that C is automatically 5. But if it's not that case, for example, when A is 14, well, we'll just go with 3, 4, 5. So for example, if you didn't memorize the Pythagorean triple, to get C, you would do C squared equals A squared, so 9, plus B squared, so 16. And so C squared is going to equal 25, so C would be square root of 25, so it'd be 5. Now, of course, since we took the square root, we should be getting plus minus 5, but we know that a side is always going to be a positive length, so we're going to say that C is equal to 5. Now we're going to look at, and also A, B, and C are whole numbers. Now we're going to look at the next concept. And so it might be interesting to observe that for a quadrilateral, which is a shape with 4 sides, the sum of its 4 interior angles is 2 times 180, which is 360 degrees. So for whatever quadrilateral you have, for example, it can be like a quadrilateral that you don't know the name of, but still if it has 4 sides, and famous quadrilaterals like squares, rectangles, rhombuses, trapezoids. All quadrilaterals, parallelograms, so all quadrilaterals have the sum of an interior angle of 360 degrees. And so, for example, for this trapezoid, well, it's not a trapezoid because we do not have a parallel side, right? So, just to sidetrack a little, for a shape to be a trapezoid, we need to have a pair that's parallel, but we see no parallel sides. So we're not going to call that a trapezoid, although it looks similar to one. So this is just a quadrilateral. And so we can divide this quadrilateral into 2 triangles, and each triangle has 180 degrees. So the sum of this entire quadrilateral is going to be 360 degrees. Now we're going to look at the next concept. And so the next concept says, for a parallelogram for which there are two pairs of parallel sides, so these two are parallel, and these two are parallel. So there are two parallel sides for this parallelogram. And then we have angles A, B, C, and D. We know that angle A and B, since they're in one straight line, angle A plus angle B is equal to 180 degrees. Angle D plus angle C is equal to 180 degrees. And we can also think of it horizontally. So angle A plus angle D is equal to 180 degrees, and angle B plus angle C. So we have angle A plus B is 180 degrees, angle C plus C is 180 degrees, angle A plus D is equal to 180 degrees, and angle B plus C is equal to 180 degrees. So this was a misprint. It just repeated the same thing twice, but it was supposed to write this. And so for an isosceles trapezoid, which means that, of course, the bases are supposed to be parallel. The bases are parallel by definition, since we need one pair that's parallel. And for the trapezoid to be isosceles, the two other sides must be equal. With equal length, for an isosceles trapezoid, there are a pair of parallel sides, so in this case the base, and two identical sides. And we know that it's identical because of the tick mark that represents that those two are identical. And so for an isosceles trapezoid, angle A plus angle D, these two, in a straight line is going to equal 180 degrees. The same thing happens for angle B and C. So that's going to be 180 degrees. And since the trapezoid is isosceles, angle A and B is going to be identical, and angles D and C are going to be identical. Now we're going to look at some examples that use the concepts that we learned just now. And so example 1 says, 3 lines intersect one another to form a triangle. Find angle D. So 3 lines intersect one another, and we're going to look for angle D. And so sometimes we need to draw angles ourselves. And so over here, we see that there's a straight line. And so this purple angle, we'll say angle A. So A plus 130 must be equal to 180. So A must be 50 degrees. So we'll write 50 there. And then for these two, we learned previously in the concept that when they intersect, the angle that's facing each other are going to be identical. The angles here are facing each other. So this angle B is going to be 45 degrees. Now we found 2 interior angles, so we're now going to look for this blue angle, C. And since we know that the sum of the 3 interior angles for any triangle is 180 degrees, we know that angle C is equal to 180 minus 45 minus 50. And so that would be 130 minus 45, which is going to give us 85 degrees. So we know that the blue angle is going to be 85 degrees. Now, following the same concept that we learned for the straight line, we know that angle D plus 85 degrees is equal to 180 degrees. And so we know that angle D is equal to 180 minus 85, which is going to be 95 degrees. So we know that angle D is equal to 85 degrees. And we have example 2. And so in example 2, a rectangular piece of paper is folded as shown. And it says find angle A here. So we're first going to look for this angle here, and we're going to call it angle B. Since we know that this is a right triangle, the right angle is going to be 90 degrees. So we can find angle B by using the concept that the sum of the interior angles of a triangle is 180 degrees. So B is going to be 180 minus 90 minus 75, which is going to be 90 minus 75. So B is going to be 15 degrees. So angle B is 15 degrees. And then we know that this angle is 20 degrees. And so since we learned this concept, where A plus B plus C is going to equal to 180 when the line is straight, we're going to draw a straight base line. And if we have a straight line, we know that we have these two angles included. And this purple angle is going to be identical to this 15 degree, and this purple angle is going to be identical to this angle. So what we have is 15 degrees plus 15 degrees plus A plus 20 degrees plus 20 degrees, and that should all add up to 180. So we have 30 plus A plus 40, which is equal to 180. And so A plus 70 is going to be 180, and A is going to be 110 degrees. So angle A is 110 degrees. Now let's take a look at the next example. So example 3 says ABCD is a square. Triangle BPC is an equilateral triangle. So it's an equilateral triangle, so all three sides are going to be identical, since it's an equilateral triangle, and all three angles are going to be identical. And since all triangles have a total interior sum, it has a sum of the interior angles of 180 degrees. If all three angles were to be identical, then it would be 180 divided by 3, so each angle would be 60 degrees. So we'll just keep that in mind. For any equilateral triangle, the angle is 60 degrees, and all sides are equal. And AB equals BP, so we'll denote that using these two ticks. And CD equals CP. And now we're going to find angle ADP. So we're looking for this angle. And instead of using two different ticks, we're going to use the same tick. And that's because we know that BP is equal to PC because it's an equilateral triangle. And so that would essentially mean that AB, BP, PC, and DC are all equal. And again, we're just going to write the 60-degree angles for the equilateral triangle. And so because we have two equal sides like so, we know that triangle ABP, so this triangle, is equal to, well, not the triangle, so we're going to write the angle ABP is going to equal the angle DCP, like here, this angle and this angle. And since we have a square ABCD, we know that each angle is 90 degrees. But then since we know that this angle is 60 degrees, we know that this angle must be 90 degrees minus 60, which is going to be 30 degrees. So both angle ABP and DCP are going to be 30 degrees. And then we're going to look for angle CDP here. And angle CDP angle CDP is going to equal angle BAP here. But also another thing that it's going to be equal to is, since we have two identical sides for ABBP, these two have identical sides. This triangle has two identical sides. And DC is equal to PC. Because DC is equal to PC, we know that triangle PCD is an isosceles triangle. And for an isosceles triangle, we have two identical sides and we have two identical angles. And so angle CDP here is going to be equal to angle CPD. And since those two are equal, we already know that angle PCD right here is 30 degrees. And so to find one of this angle, what we're going to do is we're going to subtract 30 degrees from 180, and then we're going to divide it by 2, since these two are equal. And so that's going to be 150 divided by 2, which is going to be 75 degrees. And so, because, again, it's a square, angle ADC, so this angle is a 90-degree angle, so it's a right angle. And so this angle is what we're trying to look for. So we're trying to look for angle ADP right here. And so we know that angle ADP plus angle CDP is going to equal to 90 degrees. And we know that angle CDP is equal to 75. So angle ADP is going to be 90 degrees minus 75 degrees, so it's going to be 15 degrees. So angle ADP is 15 degrees. So now we're going to go through two more examples for the triangles. So for example 4, in the diagram BE equals AC. So BE equals AC. And angle CAE here is 30 degrees and angle AEB is 70 degrees. And we're looking for angle ABC. So since BE is equal to AC, we can cut along AE and paste AC along BE. So instead of drawing, I'll just look at this diagram. So what this means is we're going to cut along AE like this, and then we're going to paste AC. Well, we're going to paste this triangle to this triangle. And so since this, I'll do it in purple. Since BE is equal to AC, we're going to bring this side and stick it to this side because they're equal. And so that is going to have an effect of making a triangle like this, which is shown here. So now we're going to work with this diagram since they drew it much more cleaner than me. And so now that we have that pasted triangle, the figure then becomes an isosceles trapezoid because these two lines are going to be parallel. And then we have two identical sides. And so based on the concept that we learned for an isosceles triangle, in the original figure we know that angle AEC is equal to 110 because that's going to be 180 degrees minus 70 degrees because it's in a straight line. So we know that angle AEC is 110 degrees. And so now, after we pasted it, angle AEC is going to be this angle. and here they wrote it as E prime. So this little apostrophe is going to be called prime. So we're going to call it E prime. So that's going to be 110 degrees. And since we have the 30 degrees here, we know that angle BCE right here is going to be 180 minus 110 minus 30, which is going to be 180 minus 140. It's going to be 40 degrees. And then we know that angle ABE prime, so this angle, is going to be 360 degrees, which is the total angle sum for the entire angles inside, the entire interior angles inside the trapezoid. Then we're going to subtract 110, and then we're going to subtract 110 again, since it's 40 plus 70. And these two angles are identical to each other. And so we're going to divide that by 2. And so we're going to get 250 minus 110 divided by 2, and that gives 140 divided by 2. So each of these two angles are going to be 70 degrees. And since the angle we're looking for is angle ABC, well, in the original triangle, ABC is going to be this angle. So in this case, the angle we're looking for is here. And since we know that this angle is 30 degrees, we know that this angle, we're going to call it x. So angle x plus 30 degrees is going to be 70 degrees. So x is going to be 40 degrees. And so we're going to say angle ABC is equal to 40 degrees. Now we're going to look at our last example. So it is given that triangle BAC equals 108 degrees. AD bisects BAC. AD bisects angle BAC, and AB plus BD equals AC. And we're looking for angle C. Now we're going to find the midpoint of AC, and we're going to call it M for midpoint. So because M is a midpoint, we know that AM is equal to MC. And then, so AB is then going to be equal to AM. Right? So AB is going to be equal to AM as well as MC. And that is because AD bisects angle BAC, so these two are going to have the same angle. And so AB is going to be equal to AM, and since AM is equal to MC, we have this relationship. And then angle ABD is identical to angle ADM here. These two are identical angles. And so we know that BD, line BD, is equal to line DM. And that line is going to be equal to CM, because DM equals CM. And now to find angle C, we're going to look for angle CDM, because this triangle is an isosceles triangle. So these two angles are identical, and these two sides are going to be identical. And so to find angle C, we can find angle CDM, and these two angles are going to be identical. So we're going to look for angle CDM. And that is going to be 1/2 of angle AMD. And angle AMD is over here. That's going to be our exterior angle. And so that exterior angle, so angle AMD is going to be the same angle as angle B. And so what this becomes is 1/2 times angle B. And since we know that angle I know it's a little confusing, but follow along. Since we know that angle BAC here, I'll just do it with a different color. So since we know that this angle is equal to 108 degrees, we know that angle B plus angle C plus angle A must equal to 180 degrees. And so angle B plus angle C is going to be 180 minus 108, which is going to be 72 degrees. And so, since angle B plus angle C is 72 degrees, and angle C is 1/2 of angle B, angle C can be written as 1/2 of angle B. And so that's going to be 1/2 of angle B plus angle B. And so that is going to be 3/2 times angle B. Basically, 3/2 times angle B is going to equal to 72. And so angle B is going to equal to 72 times 2/3, which is equal to 48. And since we know that angle B is equal to 48 degrees, we found that angle C is equal to 1/2 of angle B. And so angle C is going to be 1/2 of 48, which is going to be 24 degrees. So this problem is a really tricky one because it involves multiple steps, but with practice, I'm sure that you guys can get used to this. And now we're going to quickly go over percentage. So in percentage, we're going to expose you guys to various types of percentage problems combined with multiple topics, some that we covered in the previous videos. So for example, a percentage problem can be combined to the topic of ratio or in speed problems. And we're also going to learn about different ways to represent percentages using charts such as bar charts and pie charts. And so we're going to look at the first example. So it says, the wholesale cost of a TV is $4,800. At the store, it is marked at 20% above its wholesale cost, but later sold at 75% of the retail price. And so this is a multi-step question. And so the wholesale cost is $4,800. And it's marked at 20% above the wholesale cost. So the retail cost is going to be 4,800 times 120 over 100. So 100 over 100 is 1. So since we added 20%, it's going to be 120 now. And so that tells us that the retail price is going to be 48 times 120. And so that is going to give us $5,760. And so we know that the retail price is $5,760. But later on, it's sold at 75% of the retail price. So the price it's sold for is going to be 5,760 times 75 over 100. And so that is going to be we'll just get rid of the 2. So 576 divided by 2 is going to be 288. So we're doing 288 times 15, and that is going to give us $4,320. So Now, to calculate the amount of loss, we're going to calculate it to the wholesale cost. So the difference between the wholesale cost and the actual price it was sold for is going to be so that's going to be $480 loss. And then we'll go over one more example. And so the base of a triangle is increased by 10% and its height is increased by 20%. Find the new area of the triangle as a percentage of the original one. So we know that the area of a triangle is 1/2 times base times height. And so the base of a new triangle is going to increase by 10%. So if B is the original base, then the new base is going to be B times 110 over 100. So that's going to be 11B over 10, or 1.1B. And the height is going to be increased by 20%. And so that's going to be 12H over 10, or 1.2H. And so with the new base and new height, and also this was supposed to be written as H, that was a misprint. And so with the new base and new height, we're going to calculate the new area. So, that is going to be 1/2 times 1.1B, which is our new base, times 1.2H, which is our new height. And so that is going to be our new area. And then we're going to compare it to the old triangle. And then since we're finding the new area of the triangle as a percentage of the original one, we're going to multiply 100 so that we can find the difference as a percentage. Then since we're dividing the same thing by itself, we're just going to cancel those out. So we have B, which can be canceled out, and we can also cancel H out. So we basically have 1.1 times 1.2 times 100%. And 1.2 times 1.2 is going to be 1.32. And so that is going to become 132%. So because it's 100, we can write that as 132% of the original triangle, or we can also write that as a 32% increase from the original triangle. And that is it for our class today, and I'll see you guys with a new topic next time.